Hello, welcome to the STS-39 post-flight press conference. I would like to introduce the commander, Michael L. Coates, and turn the program over to him. Go ahead, Mike.
Thank you, Barbara. It gives me a great deal of pleasure to introduce the rest of my crew. To my right is my pilot, Blaine Hammond. To his right is Mission Specialist Don McMonigal. Next up is Rick Heeb, Greg Harbaugh, Guy Bluford, and Lacey Veach. We were extremely proud of this flight. We feel like we accomplished all the major objectives on the flight, and we're proud not only of the job the crew did up there, working very hard for 8 days, but the people on the ground. We think we had an outstanding team put together, and I think all the training and hard work that had gone into the pre-flight planning and training paid off when we got up there. With the few minor problems we had, they were overcome quite easily, I think, and we felt like we were part of a well-oiled machine, and we'd like to extend our congratulations and appreciation to the people that worked so hard to pull off this flight. We have a movie that we put together of some of the more interesting aspects of the flight that we think will describe the major highlights of this flight. And if we could go ahead and roll the movie. After the movie, we have some slides. We took some pretty interesting pictures, we think, on this flight, and we're anxious to show you some of the better shots. Well, here we are coming out of the ONC building. Even though we were the tallest crew ever to fly in space, averaging over 6 feet in height, we still look like 7 orange billiard balls walking out there.
And even though it was a pretty much standard morning, I think you'll see in this shot of the launch, we had some unique combination of environmental conditions give us a shock wave from the, you can see the condensation from the SRBs igniting right here, right behind the stack. It's quite impressive. I think that's one of the only times I've ever seen that. Of course, we lift off the pad, and the whole of ascent was totally nominal, which I was happy to see, because it meant the last 12 months of training were pretty much wasted. Here we go into the here we go into our 140-degree roll, heading down range, and for about the first 2 minutes, we're all just pretty much along for the ride as we ride the solids. Interesting view here of the shock pattern coming off the tank, and about 2 minutes of ascent, we get ready to separate from the solid rockets, and that, of course, all went nominal as well. And then for that point on to MECO, we are riding the 3 main engines, and just a real nice smooth ride, gradually increasing the G up to 3 Gs at the time of main engine cutoff. Beautiful day in Florida, beautiful day to be flying up into space. Nice early morning launch.
Once we got on orbit and we got to go from the control center, Lacey and I went to work opening the payload bay doors. The payload bay was very clean. It was a real testament to the folks at the Cape who did that sort of work. The footage you're seeing here is actually sped up about 4-to-1 ratio, so the doors open about a quarter of the speed normally. But all that went just fine, and it was great to see the real hardware out there that we trained so hard in preparation for operating, and we were ready to go to work.
Shortly after getting the doors open, the blue shift started getting ready for bed on their first day. And we got the arm out and scanned along the payload bay here from the elbow camera in the aft. You can see AFP 675. Here we're now come to the SPAS carrier spacecraft. And then as we pan the camera forward in the payload bay, which is kind of to the left from the elbow camera view, you can see STP-1 Space Test Program payload that carried a number of different gas canisters. At the top of this screen, it's a little bit dark. You can see the various CRO gas release canisters which were later in the mission deployed, ejected out of those cans, and now we're scanning forward to the cockpit area, the forward bulkhead.
We started collecting science data with 675 just a few hours after getting on orbit. That was a shot of me in the cabin, and I'm running the Cirrus infrared telescope through its paces here, getting a little bit of a feel for how the gimbals worked. not taking science data right here. In the foreground, you can see URA with the logo and the American flag on it, the Uniformly Redundant Array, the X-ray telescope that we carried on the 675 pallet. And back in the right side out of view is the far UV.
This is a shot from the Cirrus telescope, the low-level light telescope showing the aurora off the South Pole. We got some very spectacular shots of the aurora, and you can see that there in this shot here. Off on the left, you can see a little air glow. This is another shot, once again, of the aurora, and it's sort of like a dancing curtain of lights, very green lights, glowing lights as we fly through it, and if you, on some of the film, it gets a little reddish at the top. And in this shot, you can see the air glow about 90 kilometers above the Earth, and we did an awful lot of study of that.
In addition to using the cameras available to us on the payload bay, we used, or on the payloads, we also used the orbiter's low light level TV in the payload bay to take some pretty magnificent shots of the Earth. What you're seeing here, the bright splotches in the top of the picture, are the Kuwaiti oil fields, which are burning at this time. And you can compare that to some of the clouds in the lower left where we had some lightning that we were able to see from space. You can see that the oil fires were burning very brightly. This is another aspect looking northwest up the Persian Gulf at the Kuwaiti oil fires with Saudi Arabia in the lower left and Iran in the lower right.
At the end of Blue Flight Day 4, Blue Shift Flight Day 4, it was time to get ready to deploy the IBSS spacecraft. We'd completed the Cirrus observations for the most part, and here I am grappling the spacecraft and unberthing it. I maneuvered the IBSS to its release position and handed over from there to Rick, who actually executed the release. The unberthing process was very straightforward.
The release was extremely smooth, as all of them have been with the RMS. There was no tip-off at all that we could detect imparted to the SPAS spacecraft, and it sat there just as steady as could be for several minutes until the set maneuver could be performed. Well, here's us inside the cockpit. You can see that we had every camera available and every crewman available.
And just after the release, we wanted to test out the attitude control system of the SPAS spacecraft, so I commanded it through a maneuver that took about a minute. That was slightly faster there.
There's the separation maneuver. We tried to get a 2.2 foot per second separation velocity, and we speeded that up about 4 times, so it looks like we engaged warp right there, but it was much smoother than that.
It's a real pretty shot with the moon in the background. Here you can see the SPAS looking back at the Earth. You see the Earth background as we did the set maneuver and more or less flew over the SPAS on our way back to the far field position. The plume operation came next, and Guy has the camera scanning around the cockpit. We had every available crewman with a job to do, and you pretty much had to stay in your spot, as we talked about before the flight, in order to do your job. We had really, each person had at least one job, and sometimes folks had 2 jobs, and the communications were interesting as we called back and forth across the cockpit to pass data one way and the other. And it was really interesting to watch this whole thing in progress.
Once we got to the far field, Rick and Greg pointed the SPAS back to the orbiter, and the bright spot you see there in those flashes are the actual orbiter executing some RCS burns. And just another point into the cabin to show you how crowded and how busy we all were in these particular events. This is the ohms burn that one of our major objectives with the IBSS, and that flash was the ohms lighting off, and you can see the lightly shaded portion is the continuous plume for 20 seconds. At the end of 20 seconds, the ohms will automatically shut off, and you'll see sort of a spurting effect as they do, and then following that you'll see a bright flash, which we think is the purge, the nitrogen purge, which expels all the remaining propellants out the lines through the nozzles.
After completing the ohms burn, first plume burn, we did what we call the Malarkey milkshake maneuver, named after John Malarkey, who came up with these procedures. Within 5 minutes, we had to swap ends on the orbiter here, shown 6 times real speed. where we pointed back in the direction from which we came and got set up for another Ohms burn to take us back to the previous position and get set up for another series of Ohms plumes. This is what it looked like at the near field. You can see the RCS jets firing here. In this case, you'll see 4 jets fire at once. And then the Ohms burn from the near field didn't show up quite as clearly as the far field.
There goes the first of the 3 chemical release observation sub-satellites. We didn't deploy them this quickly in flight. The first one was at about 3.5 days, and the third was at about a day later. In a second, you'll see the Crow B observation looking at one of the rocket propellants in the canister. It was a pretty spectacular view. We're sorry we don't have color film of this. We could see this very clearly on our monitors in the cockpit as the gas cloud expanded very brightly, and then, as you'll see here, continues to expand and then begin to fade. And then in the middle of the cloud, you'll see the canister, the now empty canister, reappear, that little dot. And in a second, you'll see its beacon flash. It had a beacon to help us find it.
It's a star moving in from the bottom.
Yeah, that's right. That's a star coming up into the field of view there below.
The CIV gas release occurred also at the near field, and this is one of the gases. We released 4 different gases from within the payload bay. That was nitrous oxide, the only one of the 4 we could see.
The rendezvous itself took an awful lot of crew coordination, with 7 of us up there executing the rendezvous as well as the Crow observation at the same time. It took a lot of crew coordination, and it was really a lot of fun to see it all come together and work in the orbiter like it did in the simulator.
Mike got the SPA spacecraft stabilized just out next to the orbiter, and it was an easy task to reach over with the RMS and make the grapple here. And once we had it grappled again, we did another one of our interesting handovers, and I passed the controls back to Greg.
What you're seeing here is one of the experiments we did with the IBSS later on in the mission. This is the out of field of view rejection, where we simultaneously maneuver the orbiter and the IBSS using the arm to approach and then back away from the sun. And what we're looking at is the sensor response as it approaches and moves away from the sun. This is actually 4-to-1 speed, so you're actually seeing it happen much more quickly. It's a good example of the operational complexity that was designed into this mission and how we used every facet of both the arm and the orbiter.
Early in the mission, we knew we had a problem with one of the sets of tape recorders on the AFP-675 payload, so Blaine and I performed an in-flight maintenance procedure that was extremely well developed by the ground. We executed a procedure by which we spliced into a couple of wires to be able to send the data to the ground instead of record it on board.
Guy had to make sure the FP675 was safe and powered down before we went in there with all these wires. And it's not a great feeling to cut into a wire when you're not sure, totally sure the results. But we were glad to hear a few days later that they were getting great data, and it helped make that part of the mission stay alive and continue working.
During the mission, one of the things we participated in were a lot of medical tests, because as we move into longer and longer missions, we're concerned not only about how the body adapts to the space environment, but how it readapts when you come back home. And we participated as a crew in 25 different medical tests, and as you can see there, I'm wired for sound.
Here, Lacey and I are changing out the lithium hydroxide canisters in our warp drive unit, our air cleaning unit, which purifies the air for us to breathe in, and involved removing the treadmill, and just basically we had a big storage volume full of these canisters. We changed them out twice a day. Just part of our normal housekeeping activities on orbit.
One of the many things that aren't advertised as things that we do to stay busy.
We didn't have a whole lot of air-to-ground time to show the crew in the cabin. At one point they called up and said, "Oh, we've got a few minutes where we don't have to look at the payload. Can you show us something?" So I decided I'd give a little demonstration of how to prepare food, and I think it was Kathy that said, "Why don't you make a peanut butter sandwich?" And I had to laugh, because that's the one thing I cannot stand to eat is peanut butter. But I broke out a tortilla and made a peanut butter and jelly sandwich. Fortunately, Blaine will eat anything and everything, so after I put it together and so forth. I floated it to Blaine, and he ate it right there while I was on TV, and that's as close I've ever come to being sick on orbit as watching him eat a peanut butter and jelly sandwich.
You need a little more jelly, boss.
A little more jelly next time. But I talked to a lot of schools, and the children love to learn how you eat in space and prepare food and so forth. And that galley is just fantastic. It's such a quantum leap from the early flights. My first flight where we didn't have a galley and we had a metal food warmer. The galley is just fantastic.
This is a shot of Rick shampooing his hair doing an ohms burn. And we, on our flight, did 16 ohms burns, and you can see the effect it had in the cockpit, throwing everything either one direction or another.
We also did some informal science experiments on board. You can see here is a bubble of lemonade and a bubble of strawberry drink, and the surface tension has the two bubbles bounce off of each other without combining in our first attempt to try to make them combine.
Mike, perhaps unknowingly, had laid down the gauntlet there because he had said that they had tried to do this in a previous mission unsuccessfully. So, of course, we had to demonstrate that it could be done, and that's the first known lemon berry juice in flight.
And I would strongly recommend that you not drink that stuff at home.
Well, as Greg put it, everybody's got to have a way to unwind. And it was a tight fit, but it was kind of interesting to see how you spin about an axis, and I turned out to be a pretty good subject for spinning. Maybe I'm just tall enough to fit in there. Don popped his head out of his sleep station there to see what all the racket was. And I think he just gave up in disgust and closed his door.
I thought it was a bad dream.
On orbit, Don and I were scheduled for some other medical tests involving running, and I couldn't figure out why I was sweating so much, but I guess it's this metal object and all these straps attached to my feet here, but he seems to be having a lot easier time of it than I was, and fortunately, after 5 days, I broke the treadmill, and we couldn't do any more of that.
We appreciated that. Here we are strapped in for entry. I'm about to put my helmet on. The entry was fascinating for me because we came right down the center of the United States over the heartland of America on a pretty clear day. And going Mach 20 at 200,000 feet is a fantastic feeling. We could see the cities and airports and so forth just whizzing right by. We passed up an airliner. I wanted to wave and so forth, and it was really quite a feeling coming in for entry. I think everybody was ready to come home after 8 days of working hard up there, and when they said we're going to Florida instead of California, the crew said, okay, whatever it takes. We did a braking test as planned, except for a max brake pulse at 70 knots. And I was surprised it slows down very quickly at 10 foot per second squared, deceleration rate. We didn't waste any runway.
This is a shot of the crew coming out of the orbiter. I think we caught KSC by surprise on this landing, and it took them about an hour to get us out. And as we come down the stairs here, we're sort of trying to get our land legs under us as we descend back and make the adjustment back to 1G. At the bottom of the stairs, we had a welcome from the management. General McCartney was there, as well as Bob Seek, and welcoming us back, and we sort of expressed our appreciation for being back. And this is a shot of the crew after completing 199 hours in space, 134 orbits, and a little over 3 million miles of travel.